Good morning. Yeah, there'd be right. You can go ahead. Good morning. Good morning. We're good? Welcome to Understanding Bridge Inspection Report. And I'm Holly Winston from Local Agency Bridge Inspection.
You're going to have to really speak very closely to that one.
Okay. Okay. Welcome. We're going to try this again. I'm Holly Winston, Senior Local Agency Bridge Standards Engineer, and we're going to today talk about inspection reports and how that information could be useful to you. And we gave this training 3 years ago, but maybe a lot of people been missed it, and I got a feedback that we would like that again to. So those who have not attended and would like information are welcome. We have 4 experts today. Rich is going to provide us with the bridge element information, and then Jeff's going to provide us with the supplemental inspection report that feeds to the primary report. And then I'm going to talk about Scour evaluation and updates. And lastly, but not least, Bert's going to talk about load rating, and everybody's very interested in talking about load rating and what that does to your bridges. So I think first one up is Rich, and I'm going to introduce Rich. And Rich is a local agency bridge inspection engineer. He's been with ODOT for 9 years, and he worked with a consultant before that. And we have to say thank you to Rich because he was served in the Navy, and we just came back from Memorial Day. So when you have chance, say thank you. Please welcome Rich.
All right, thank you. Let's see. Okay, so today I'm going to talk about really about some of the changes that have occurred over the last couple of years between our old report format and the new report format. Try to help you understand what you're looking at when you get these reports. And so the purpose, we're going to familiarize really what the changes are. Those were federal requirements. AASHTO had changed their element or way that they were looking at the element condition states, and then how that really affected us on our end and the reports that you guys receive. So some of our objectives, we want to identify those changes. We want to understand how they affect the format of the report, and then we want to kind of help you understand what the element language and the defect language actually means when you're looking at some of these things. Some of our major changes in the ODOT or the AASHTO coding guide is ODOT originally was using defect flags to identify objects. So if we had, if we were looking at, say, a concrete girder, we might have a smart flag or something that would just raise an awareness that something was happening. And then AASHTO, a couple of years ago, decided that we needed to start actually quantifying those defects. So we changed them from the smart flags to the defects. And then we also have associated a condition state for all of the different elements and the defects that go with those. One of those changes also is that we kind of are addressing the defects in a more uniform manner. Before we would have, we could have like only 3 condition states for a certain defect, or we might have 5 condition states for another defect. So AASHTO decided that they were going to go with 4 condition states, which is actually kind of aligns itself with how ODOT had been looking at things originally. And that was kind of in a good, fair, poor, and then it needs to be analyzed kind of thing. So now our condition state 1 is your bridge is in good condition. Your condition state 2, it's in fair condition. Your condition state 3 is your poor, and then your severe condition state 4. And we'll talk a little bit about that and look at some examples. Some of the other changes we on the reports, and again we're going to look at some of those, is that we've added the defects on the report under each of the parent elements to help identify. So when you're looking at your report, you can get a quick glance and see where your issues really lie, instead of having to go back, read through all the remarks, and try to figure out what was going on with your structure. Another thing that was changed is that on the load rating section, there were new axle configurations for the special haul vehicles. And actually another change that has just occurred is for the emergency vehicles, and Bert will talk a lot more about that. So what we're looking at right here is we're going to look at some of the defect language, just to give you some examples. It also shows we're looking at some of the pages out of the Oregon coding guide. What Oregon did was we had originally created what we call an Oregon coding guide. It took all of the pertinent information out of our inspection manual and downsized it into a pocketbook that the inspectors could use for quick reference out in the field. So we had to update that to reflect all the AASHTO changes. We added in the defects, the new quantity unit of measures, things like that. So this is just kind of a snapshot of one of the little sections inside of the coding guide, and it reflects, again, the AASHTO changes. So this one is on the concrete defects. This front page is going to tell just a list of all the different elements. You'll see it has a list of all the units of measure. And then we have a quick reference. And again, this is just kind of an overview of where the inspectors are pulling their information. You're not going to see a lot of this on your report, but it's good to know where they're getting their information from. So this set of values then tells them what pack of defects are associated with each of those elements. So on the next sheet over, we look at a list of all of our defects. And then at the top, you can see where the condition states are listed. This is the good, the fair, the poor, and then condition state 4, which is usually requires analysis. That's where we're saying this actual element has enough deterioration that we need to get an engineer to look at this. So next to each of the defects, you'll see some description language. And this is what the inspectors in the field are going to use to quantify and decide what condition that particular element is in. So if you were looking at cracking, cracks can have condition state 1, but they're really small, minute cracks, pretty much like what we would just call a shrinkage crack. Nothing that we really need to pay close attention to. We want to put it on the radar to say, okay, this could become an issue down the road. Condition state 2 starts to look at, we're noticing cracking is a little bit more closely spaced, the size of the cracks a little bit wider. So again, it's just quantifying that defect that the inspectors can then relay to the bridge owners to let them know what's going on with the structure. So some of the major changes for ODOT is that some unique elements were added to what previously ODOT was using. A couple of those were the paint systems. They started to the coating systems. So like on your bridge rail, if you have a galvanizing on top of the Type 2A or your tri-beam rail, we want to let you guys know what condition that kind of coating is, or if your steel girders have been painted, we want to be able to capture how that paint system is handling or standing up to the weather, if it's in good condition or not. Also added were the unique defects. Again, there's way too many to kind of talk or throw at you right now, but again, based on what we were showing you on the previous sheet with the different defects for each of the different material types, cracking, wheel track rutting, corrosion, missing connections, the list goes on. But ODOT had to incorporate those into the coding guides and figure out a way to describe each of those. One of the unique kind of things about the protective coating systems, the wearing surfaces, is that they are really just kind of looked at overall as an effectiveness. We're not associating defects with those at this time. And the main reason is that the feds are not collecting information on those. So we didn't feel at that point we need to get really too detailed. We could just let you know that the AC is really not doing what it's supposed to, or if it's in good condition or not. So now we're going to look at what the old condition or the old inspection report versus the new inspection report layout looks like. So on the left-hand side, this is what ODOT previously was using. And you can see the header information at the top has pretty much all stayed the same on both reports. What really has changed is down here in the condition state area. We are listing out, on the old report you listed out the element, and then you had a description of the condition state off to the side for that particular element. And it was on a percentage basis. On the new report, you have your parent element, and now you're going to have your list of defects that go with each of those elements. So these are the things that have been noticed as there are issues. If you had cracking or any of the other defects, I have to apologize. My eyes are changing and I can't quite read the screen from here. So one of the defects here, the efflorescence. So that's the white powder that forms in the cracks where the chloride is leaching through on the concrete. And then we're going to talk about how each of the defects are quantified. So this one has some in condition state, looks like condition state 1, and some in condition state 2. So you have some that's in good, some in bad. And then that all rolls up into your parent element, which is your deck. So again, the changes really are, we've added in the defects. We've done a uniform condition state 1, 2, 3, and 4. And then we've gone to...
How do you come up with that number, though?
And we'll talk about it a little bit later, but the question is, how do we come up with that number? Because of we'll use the concrete girders as the example. It's on a linear foot. So let's say our bridge is 20 feet and we've got 5 girder lines. So we got 100 feet of girder. So that as they go through and they're inspecting, they're going to come along and they'll say, okay, I've got a crack at 3 feet in from the end of the girder. So they're going to quantify for that 1 foot section a crack, and we're using that 1 foot because that's what the AASHTO and the feds have decided is you do it per unit. So in that 1 foot, we'll say there's 1 crack. Now they'll go along and they say, okay, I've got another 15 feet of cracks along all the other girders. So you'll quantify and you'll say, okay, I had a total of, let's say I had a total of 15 feet of cracking. That's how they're going to quantify. That's how they come up with the number. If you're talking about your decks are going to be on a square foot. So then they go through and they say, I had, we're going to, for ease of computation when you're in the field, we just assume that a crack's going to be a foot wide for our computation, and then they'll measure the length. So if you had a crack, you know, say an 1/8 inch crack, and it was 5 feet long, we would say that would be 5 square feet of cracking. Yep. So here in the condition state, really the changes are we went to, like I said, we added in the defects. We've changed the unit of measure, and now we use the condition states 1, 2, 3, and 4. One thing I do want to point out, because we'll talk about it a little bit later, is this little section below. The NBI category, this is your snapshot of your bridge, your overall condition. And again, like I said, we'll talk about this a little bit later, but this is really the only sheet that shows it. So I want to point it out here. Your deck, your superstructure, and your substructure. These 3 items right here are going to give you how is my bridge doing. This is your good snapshot of your bridge at this point. These numbers from the condition states, the inspectors will use those, and they will say, okay, overall, let's say I had a little bit of cracking in one of my girders. They're going to come back and they're going to say, how does that apply towards my whole superstructure? If I have cracks just in one little section, but the rest of the girders all look good, then you're going to have your superstructure NBI condition state is going to read as good because everything looks good on your structure. So really that's a snapshot of your bridge. That's really an important thing for the local agency, people that are getting these reports. If they want to know how is my bridge doing, right there, those 3 values are really going to give you a good snapshot of where you stand. So some of the element changes, again, ODOT was using its own version of element inspection before AASHTO made the changes, so there weren't a lot of things that ODOT had to change to update the program, but one of them that we ran into were how we're identifying the difference between columns and piles. So one thing that we've looked at is that piles were driven into the ground, and then columns were something that ended in a footing. So if you're looking at your report and you're seeing these and, well, what's the difference? That's how ODOT elected to split the difference and figure those out. Abutments, again, especially on the local agency side, you get quite a hodgepodge of material types that get used to put these structures together. So we went ahead and we are using the horizontal predominant load carrying member is what we're going to use to identify the abutment. And what I mean by that is, so if we have a concrete cap, so that's cap going horizontally, sitting on top of some timber pile, and you've got a timber back wall behind that, we're going to call that a concrete abutment because the main load carrying member is the horizontal concrete section. So what that then brings up is that, well, how do you capture any timber defects, like if you have decay or splits or cracks in the timber, how does that get put onto concrete? And we are allowed to put multiple material defects on the main material parent. So if you have that, like say a couple of your piles underneath your concrete cap have decay, you still can put, you would say like I've got 1 foot of decay in my concrete cap, which sounds kind of silly, but it's the only way that we can really capture what's going on for the whole section. All of your bridges are going to have abutments, except for there are a few cases where you have the cantilever bridge ends. So those bridge ends are just kind of floating out there. Those bridges will not have an abutment. And then at your abutments, if you have a multi-span bridge, and say you have 2 spans, you're going to have an interior pier, and you might have a cap on that particular interior, but we're not going to call it a cap at the end. That's called an abutment. So when you're looking at the elements, if you're trying to quantify what you have for your structure, we're going to you'll have an abutment at each end, and then in the interior you might have a cap on top of piles. The railing is similar to the abutments, where it's the main horizontal element that's going to determine what we're calling it. Steel rails with a concrete post, that's going to be quantified or called out as a steel rail. And then again, just kind of talking about you might have multiple defects, material defects on for the overall parent. So again, if you had like a steel rail with concrete post, you might end up having spalling or exposed rebar showing up on your steel rail. Trusses, we used to break out into a top and a bottom chord, but AASHTO changed it to now we're just looking at a truss line as one unit, and it's on a linear foot. We don't separate that out anymore. And then the other big change was that ODOT used to use percentages to quantify the items that we found wrong, but we went with units of measure now. So this was kind of an example talking about like the steel railing with the concrete defects, just to show where how these might appear on your inspection reports. So here you have your what we call the parent element. It's the main item, and then each of the defects that are listed underneath it. So the 4 condition states, like as we mentioned before, condition 1 is your pristine or your good condition. Your CS4 is severe or it has failed and you need to perform analysis. The defects versus what, like I said, ODOT used to use the smart flags. And then each of the, again, we'll go back one here. Again, this is called you'll hear a reference to this. These are called the parent elements just because it's the main. And then each of these were referred to as a child defect because it rolls up under this. And when we say this is how it's reported to the feds, is the main item is what is actually the values get reported to the feds when they're measuring us against the metrics that they have in effect. And we've talked about quantities and percentages. One thing to note is protective coating systems. We'll talk about that here. I'll show an example. It'll be easier to understand it. So on our parent element. So we're going to look at decks. Here's a list of the defects. Here's our quantities. For each parent element, you're going to have a total quantity. So here's your total quantity of square foot for this deck. And then under each of the defects, you're going to notice it has its own quantity. Those quantities for the defects are going to add up to be to match the total in the parent element quantity. The exception is going to be if you have a protective coating system or a like an asphalt wearing system. Those quantities can exceed because they're a protective coating. They're not a unit of measure under the parent element. And it's a little confusing to understand why they did that. But that's just what you're going to see on your reports. Okay, so we'll look here. You're going to see that there's an environmental factor that you might see and you might be wondering about on your reports. This one has most of the things are in a moderate environmental condition. And what that is you have 4 conditions. You have benign, which is there's no impact on the structure or the elements from the environment. You have a low, a moderate, and a severe. And generally, if you're on the coast, you're going to see more severe. The valley, you might see low to moderate. And then in eastern Oregon, a lot of it, you'll see probably low. I don't think we have any benign, but it's low to moderate. So that kind of breaks it down into regions. It's not a real important thing for what you're looking at, but you're going to see these things on the report. You might wonder what it is. It's just letting us know what kind of condition the bridge is in, which also affects on how often we might want to look at these structures. If you have concrete girders, or if you've got we'll use concrete girders. So if you have concrete girders and you have a lot of severe cracks that are showing a lot of dark stained efflorescence, and we know that the structure is sitting in a severe condition, we might want to look at those cracks a lot more closely, just to ensure that we're not having an impact on the rebar inside of the girders. So that's just kind of an indicator for the inspectors to how to pay attention to doing their inspections and when to do them. And so again, here's a kind of an example on our quantities. So if we're looking at a pre-stressed girder, we're looking at our total linear foot, and then we're going to look at the defect located here for the spalls D-lams. We're showing that we have 1 foot that they found a spall in condition state 2, and the condition state, again, when we go back to the example I showed where we had the coding guide, the little example for reinforcing, the defect language for the inspectors would say, like, for condition state 2, the spall is less than 6 inches in diameter. So he would say, okay, according to the breakout in the guide, this, say we have a 2-inch spall, is less than 6 inches, so it's going to be a condition state 2. So he's going to put 1 foot of that girder into CS2. And that's, you can see how it rolls up into the parent element. And then it also gives you 1 foot of total quantity here. So then this 1 foot and this 1,609 are going to add up to give you your total quantity here. And then another example down here in the abutment. So this is what I wanted to just kind of talk about. Again, here's where you might have a steel protective coating system, and you're going to see where the quantity might be larger than the other quantity. But again, I don't think that most of the people looking at these reports are really looking at the quantities a whole lot, so I'm not going to go into too much depth on that, I think. This one is really kind of talking again about how we look at the coding systems. I mentioned before, each of the defects has specific language to identify, but the protective coding systems are, we go on an effectiveness, and condition state 1 is fully substantial or fully effective, and then substantially effective, and then pretty much non-effective, and then it's either missing or failed. That's pretty much how we look at the paint systems. We also look at your AC. I think really for you guys, that's really the good breakdown. I think the protective coating systems were the paint. So again, talking about some of the changes. One of the things when we have the defects, we ran into an issue of what do you do if you have multiple defects in the same spot? And an example of that is, say if we have a large spall in your deck, and you notice that it has exposed rebar in that same spot. Well, those are actually two different defects, because you could have corrosion on your rebar, which we have to note, but then you also have your spall. So ASHA said that we can only record one defect in that one section, and the reason being is that if you started to record multiple defects in one section, then your quantities are going to exceed your total parent. So if an example of that, say if we had 20 feet of girder, we noticed again we had a spall with some exposed rebar. If you were to say that was 2 feet of defect, well, step back. So you would say, okay, I want to say I have 1 foot of spall and 1 foot of exposed rebar. It gives you 2 feet of defects for your total girder quantity. Well, if that happened along the entire length of the girder, then suddenly you've doubled your total quantity, and you're reporting more quantity to the feds, which then that affects funding. So we have to be careful not to do that. We have to make sure that we stay within what our total length was. So the way we handle that now is that we have what we call a hierarchy chart, and the inspectors will look at that and they'll say, okay, if we have 2 defects in the same spot and they're in the same condition state, which one do we report? So we've come up with a hierarchy chart for the guys to look at, and they can pick out the worst of the 2, and then they record that as the defect for that spot. One thing that we then have told the inspectors to do is down in the remarks section for each of those to go ahead and write out and say that you have multiple and what is actually going on in that spot, so that the owners and anybody else that are coming back to look at those reports can actually figure out if there's any additional items that we need to look at, defects. And this is an example of what the hierarchy chart looks like. So if we look over here on the right page, like say under masonry, all elements. So they would look through and they would look at their list, and okay, we notice it at the top of the list is worst, and then down at the bottom is the lowest case. So on this case, we would say Scour would be the controlling element. So if we were on say a masonry abutment, it's 20 feet long, the inspector's looking at this and he notices see on the one corner of the bridge for 4 feet, he notices scour. But then he also notices that the mortar between the stone was missing. Well, then he would look through and he would say, okay, which is a worse defect that I need to record? And he would use his hierarchy chart, and scour is the highest on the list, so he would go through and he would put down scour as the main defect for that section. And I want to kind of talk a little bit about temporary repairs. This is one of the things we run into a lot of confusion kind of on the local agency side. And one thing I want to talk about is when you're doing a temporary repair versus a permanent repair. If you intend for it to be a permanent repair, we highly recommend that you either remove the old member or you alter it in some way that it is no longer part of or looks to be part of the load path. And the main reason we stress that is that once you put in what you consider a permanent repair, if the old member is left there and it's still in the same condition that it was in, your bridge is still going to be rated down because it is assumed that the old member is still part of the structure, is still attracting some sort of load path, and it has a negative effect on your structure. So if you have a rotted pile, you come in, you drive a pile right next to it, and you consider that to be a permanent repair, then we recommend that you cut the top 2 feet of that pile next to it off if you don't pull the pile off at the mud line or whatever, just to show that it's no longer part of what you consider part of the structure. So then when the inspector is out there and he's looking at your say if he gets out there and he notices something has been done to the structure and he hasn't had a chance to talk to the bridge owner, he's going to probably consider that a temporary repair, just as a general rule. And then we generally in the office will look at anything that goes past 10 years. If we've been calling it a temporary repair and it's been in place for 10 years and there's still no plan for anything to be done to change that, it's probably going to be changed over to a permanent repair, unless the county or the bridge owner has requested that it is kept as a temporary. And sometimes that is done when they're trying to look at sufficiency rating and trying to get funding for the bridge. But generally, that's our guideline. If the inspector has been out there, they notice it, and we've gone past the 10 years, then we're going to start to call it a permanent repair. So again, will the temporary repairs have an effect on the bridge replacement project? Nope, as long as we're calling it a temporary repair. And then also on the old reports, it was easy to tell if we had temporary repairs next to the condition state columns. There would have been a T out in another column to identify it as a temporary repair on that. So if we said we listed elements as piles, and then we went through and we gave our condition states 1, 2, 3, and 4. Then off to the right side of that, there would have been an additional column of a T if we had put in some temporary pile repairs. At this point, with the new reports, that they did not have the capability of doing that T. That's one thing that we're actually having changed now to get it back on there, because it was really helpful for the bridge owners and also for us and the inspectors to be able to quickly identify if temporary repairs have been done on a structure. So when we talk about the remarks, there's two ways that the inspectors can do these. They can do it just all under the main parent element if what I mean by that is if we had, say, concrete girders, they could just come back and write down, we have so many cracks and so many spalls listed, blah, 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 underneath the concrete girder section itself, or they can address under each of the defects. So, in which we've been recommending to each of the inspectors that they put all of their comments under each individual defect. It makes it easier for, we found talking with other bridge owners to be able to find those and where the defects are actually located at if they put them under each of the specific defects instead of the parent elements. But going back to what we talked about before, say if you have multiple defects in that one section, then they can use the parent element comments and remark sections to capture all those additional things that might be wrong with that particular element. Some of the items that should be captured in those remark sections are if there's additional safety hazards, if they notice like load path issues, and then scour concerns. And here we go is an example for how the remarks look. Again, we're talking about a concrete deck. Here we are in the element condition state section. We're looking at all the defects, how they've rated and quantified their condition states. And then down below in the remarks section, here's for the deck. They do have a little bit of comment under the parent element, but then each of the defects, for like here, they have the spalls, D-lams, and patches. This is where they're going to explain where their patches are, where they've noticed that particular defect. Stepping on Bert's toes a little bit, this is the load section, the load rating section. You're going to see the new special haul vehicles listed here. And then actually down below, again, you're going to see another new one on here, which is going to be the emergency vehicles, the really heavy emergency response trucks. So back to our NBI conditions, when I was first starting out, and I kind of pointed out the section we were talking about your deck, your superstructure, and your substructure. Your three main portions of your bridge. And this is going to give you the language where 9 is good, 0 is it's utterly failed, and this is the rating numerical scale for the MBI conditions. So when you're looking at those three spots and you see like a number 6, then you can go and you can just say, okay, well, it's in satisfactory condition. We have some minor issues, but everything else looks good structurally. So that's kind of just a description. This is in our ODOT coding guide, and we can provide a link for that if you guys want to be able to find that electronically. So then you guys can also go through and kind of look at what the inspectors are looking at if you have an interest, if you really want to see where all the numbers come from. Some of the some of the other NBI categories we're going to talk about, but we're going to talk real quick about the decks, the superstructure, and the substructure again. But we'll address a couple of the NBIs that go into play or play a part of determining your sufficiency rating values. This one we're going to talk really the deck, item 58, your superstructure, your substructure, and then we also look at the overall channel condition. And that's when we're looking at the channel condition, is there debris down in the water? Do we notice a lot of heavy rock deposits from heavy flows? Do we see the embanks are being eroded? That kind of stuff. Substructure, superstructure, and deck, these are all looked at as the bridge overall view, whereas the element condition states are again looked at in a per element view. So when you're doing your MBI, again, say we looked at the whole deck system and we only found a spall in one little corner, overall the deck looks good. So it's going to get probably a high value, probably a 6 or a 7. Now, if you were to say there was a hole in the deck and we had concerns of localized failure, then that will change how we're looking at the NBI, and it might drop that value down considerably. But that's really the only effect on your NBI values is if you have a localized failure or multiple defects throughout your whole system. Again, it's like if we were looking at, say, girders, and we noticed cracks every foot throughout all of our girders, then we are probably going to bring our NBI values down and say it might be a 4 or a 5. So again, our MBI appraisal items, these are items that go into determining your sufficiency rating. We're going to look at items 67, 68, 69, 70, and 72. Again, used in values 0 through 9, 9 being the best. So item 36, these are your safety features, and what those are your bridge railing, your transitions, the length of approach guardrail, and then your guardrail ends. So when the inspector's out there, and these are, item 36 is broken into 4 values. So it's a 4-digit number. And first digit in that number, or that 4-digit, is going to be the bridge railing. The second one will be your transition, and then your approach guardrail will be the third, and then the ends treatments will be your fourth. So if we look at something and we are looking at a bridge rail and it conforms to current bridge design standards, then it would receive a 1. So, and then say the rest of the transitions, the approach rail, and the ends do not conform to current standards, then those are going to be zeros. So your 4-digit value then for your 36 would be a 1000. And that's really just a quick way to see, does it conform to the current design standards. 67 is your average daily traffic comparison. It compares with your inventory load capacity. Basically, what it comes down to is, can the structure support your daily traffic? Item 68, your deck geometry, and it's going to look at roadway width, your number of lanes, the vertical clearance, and then they come up, and those values get brought in automatically through a formula to generate your deck geometry value. Bridge posting, item 70. Really, it's just looking at your load capacity to the state legal loads. Your item 71, when you're looking at your waterway adequacy, the best way that I describe this one, especially when we're out with new inspectors, is what's going to overtop first? Is it your bridge or your approachway that's going to overtop in case of a flooding event? So if you're in say if we're in a crest vertical curve, so your bridge sits higher than your approaches, you're generally going to have a high value because that's what we want. We want the water in a flood event to go around the structure, not over the bridge. So if you're in a flat land, your approaches are on the same level as your bridge, your value is probably going to be a medium value. And then if you're in a sag crest or a sag vertical crest, where your bridge is below your approaches and it's going to flood first, then your value is going to be lower. And that's, again, these are values that are going to go and affect the sufficiency rating of the bridge. NBI 72, which is your roadway alignment. This is a value that looks at the overall alignment of a section of highway, not just at the bridge, but it wants to see how does the bridge align with the section of roadway. So an example of that is if we're on a curvy road and like the picture suggests here, the bridge curves with the roadway. So when traffic comes up to the bridge, they're not slowing down because the bridge is forcing them to turn. It's the roadway alignment that's forcing them, so the value would probably be high. Say if you're on a straight section of road and you get up to the bridge is skewed a little bit to get across the stream, so they have to slow down to get onto the bridge and go across. It's the bridge that is forcing them to slow down, so the value is going to be a little bit lower. And that's really kind of covers the real big changes that we've done and we've seen in the between what ODOT was doing previously and the new AASHTO code. So if you have any questions, I could be happy to try to answer them now. But I'm also, if you want to get in touch with me, I've got my information here. I'm more than happy to set up time to either over the phone or we can get together in person and sit down and go through the reports and answer any questions that you guys have. Yes, question on piles?
Yes. If they're buried, are they still categorized?
If the piles are buried, yeah. Well, that's a good question because one thing that so your question is if the piles are buried,
Yeah.
are they still quantified? The directive that we got from the new AASHTO coding is that we will inventory whatever is visible. And we just actually had a discussion where, because we get into where if you have plans and you know that there's a spread footing or if you know that there are supposed to be pile there, should you code those or not? But the directive is if it's visible, you code it. If you don't see it, you don't code it. And I think that the reason why they're saying that is it kind of runs into a liability issue. If an inspector were to code something that he can't see and something were to happen, you kind of take on a liability issue. So the exception to that is, say, if we had a spread footing on we had a column with a spread footing that's down in the stream, and at one point during an event it had been scoured out and we could see the top of the footing. We'll say there was no undermining, but it had been visible for one of the inspections. Then they would put it on the report and they would just note down in the remarks that, say, the next inspection they came by and it had refilled in and they can no longer see it, they would leave that inventoried because they had seen it previously, and they would just make a remark that it had filled back in. So if something has been there previously, we'll put it on a report. The other thing too is that we will look at the severity of how it's buried. If we notice that somebody could get to it really easy just with like a little hand shovel, just to uncover enough that they could get in there and drill the pile or the top of the pile to expose it, to be able to see it, then that's something we recommend. Because we have a couple bridges on the local agency side where they use cribbing to build it up. But just over time, there were silt deposits up around all the cribbing. So we had found out that it's fairly easy to dig some of that out and get in there and sound it out. So it kind of depends on the situation of how much it's buried. We aren't expecting the inspectors to get in there with a backhoe and dig out everything to try to get to those things. If it's fairly easy for them to uncover it and get to, then yes, we recommend that they do that. So does that answer your question? Okay. Okay, well then I think I'll turn it over to Jeff Swanstrom. Jeff is our senior bridge inspector. Actually just retired May 1st, right? I think it was May 1st.
That's correct. Still here, though.
Yep, he's staying around to help out for the next 6 months or so to transition and train his person to fill the next spot and just help out since we're still pretty short-staffed. But and Jeff will be talking about the supplemental reports. These are reports that help define the main inspection report. So let's say if we had timber elements, like timber pile, timber girders, or something like that on our main inspection report, he'll talk about the timber-borne supplemental report, which is a document that's attached that has pictures and a schematic layout that the inspectors will go through and they'll fill out where they've noted rot or other defects. So with that.
Okay, thank you, Rich. As you can see, the routine inspection report is a compilation of everything you find out on the bridge. And what feeds into that are these supplemental reports and the various types of inspections that you might do as a bridge inspector. It's a dynamic report. Actually, it's a snapshot. The routine bridge inspection is a snapshot. But the other reports, the supplemental reports, are dynamic reports that you continually add to. There's a lot of changes to those reports. Many of them are on different frequencies, inspection frequencies. So as an inspector signs that routine bridge inspection report that you'll find on the bridge inspection webpage for that particular bridge, that particular time that he signs that report, he or she signs that report, that is the condition of the bridge. So there's numerous supplemental reports that I'll go through here. So again, the routine bridge inspection report, first of all, the bridge inspections required by the NBIS are the inspection reports that I'm going to talk about, or the inspections that I'm going to talk about. And the first one, as Rich covered in quite good detail, was the routine bridge inspections. And those are visual. Those are done a maximum every 24 months. They're visual observations of the primary components of the bridge and the bridge elements. And then we have the fracture critical inspection report. Those are steel members that are in tension. They're non-redundant. There's no redundant load path. If one of those members were to fail, there's a possibility of either a portion of the bridge collapsing or the entire collapse of the bridge. So we are required to inspect these bridges, these fracture critical bridges, every 24 months. They can be, less than 24 months, but a maximum of 24 months. And it has to be within hand's reach. You have to be within 24 inches of the member. So no drones, no anything like that. I mean, you can find indications with drones, but you have to be right there with feeling the member and touching the member. Then there's the underwater inspection reports. Those are obviously the below water condition of the substructure of the bridge. And ODOT has their own dive team. And they also look at your bridges, the local agency bridges, the state bridges, other state agency bridges. And so those are done on a maximum of 60 months. Some are on 12 months, depending on the condition of the substructure or the scour conditions. And then you have damage inspections. Those are unscheduled inspections that are either caused by environmental factors or human factors, say a seismic event, collision damage, or something like that. Then we have the in-depth inspections. And these are timber boring reports or timber boring inspections. And I'm going to go in fairly good detail on what that timber boring report looks like and what goes into that report. We also have fatigue-prone detailed reports. Those are on steel members, once again, Generally, they're redundant members. So you might say a good example of that is stringer floor beam connections. So on your deck, that supporting your deck, where you have a stringer that is connected into a floor beam. So we look for out-of-plane bending. We look for distortion. We look for fatigue cracks in members like that. And then you have special inspections. Now, there's not very many movable bridges probably on the local side. Probably most of them are in the Portland area with the city of Portland, Multnomah County. The state has about 10 of those movable bridges. And those are on a frequency as well for inspection, the mechanical, electrical portions of those bridges. And then there's pin and hangers. Now, pin and hangers can connect girders. They can connect trusses together. They connect steel members together. Say I-bars on a bottom cord, and I'll show you an example of that in one of the reports that involves pin and hangers. And then there's cross-channel profiles. And those are required to determine what is the channel. How is it moving from bank to bank in that stream? How deep is the channel around spread footings? Is there any undermining? So I'll show you that report as well. So in 2013, Federal Highway came up with the National Bridge Inspection Program metrics. There's 23 metrics that each state is responsible for making sure those are done. It's an oversight. It's a data-driven program that gives you information on the condition of your bridges. And it was established in 2013. So when I mention metrics, that'll give you a little background. Most of these reports fall under metric 10 and metric 11. And if we fall behind on any of the frequencies or getting these inspections done, then we have to go on what they call a plan of corrective action, so that we show that we're trying to catch up if we're behind at all on any of these inspections. And so here's the list. I know it's hard to read, but you can actually look it up to say the Federal Highway FHWA metrics, and you can read each one of these. But the ones that involve the reports I'm going to talk about are metric 8 through, or actually 6 through 11. But there's basically an inspection frequency for lower and high risk bridges, for fracture critical bridges, and also for any of these supplemental reports, the underwater reports as well. So the metrics were introduced in 2011, established in 2013. Metric 11 really encompasses everything, all those reports. I know I mentioned the other metrics, but basically metric 11 is all of the in-depth reports or supplemental inspections that a state will do. And that includes the routine inspections, fracture critical, underwater, the damage, in-depth, and special inspections. So the first report I'd like to talk about is the fracture critical inspection report. And as I mentioned before, that must be a hands-on inspection, done no more than 24 months, every 24 months. And it is on tension members that, if they were to fail, could cause a partial or complete collapse of the bridge. We designed a lot of fracture critical bridges in the past. We don't do it anymore. But in our inventory, I think we have probably 150 on the state side. On the local side, I'm just going to throw out a guess of maybe 250 fracture critical bridges. Probably 500? Yeah. 500 fracture critical bridges. So we have a fair number of those types of bridges that we still need to inspect and inspect them up close and in person. To rate the members on those fracture critical reports, obviously it involves steel elements, and Rich went through this in great detail. But in our bridge inspection coding guide, and the latest is the March 2015 ODOT Bridge Inspection Coding Guide, you'll see some of these steel elements on those bridges, on those types of bridges. And as I'm told, Holly said that these slides will be available to you after the presentation. So there is a website where you can pull the coding guide off the Bridge Engineering webpage. You can print that guide. It's, for those that are on the webinar cannot see this, but this is the size of our manual. It's exceeding a pocket size, but you can get it in this size if you want to print it in that size. So it's got all the information in it, and as Rich said, it's the AASHTO elements that were created by AASHTO, approved by Federal Highway, and we just reduced it down to a smaller size so we can carry it around. So the steel defects on a fracture critical inspection, the most typical you would find is corrosion, fatigue cracking, the fasteners, the condition of the fasteners that connect the members together, say on a truss or on a splice on a girder. And so you've got several defects that you can apply or that you'll be looking for, but basically you're looking at, you're not going to really give a condition state rating to those steel members on the report itself. That'll be on the routine report. But you will document whether or not they do have corrosion, steel fatigue issues, and connection problems. Here's an example of a fracture critical inspection report from a local agency bridge. You have an elevation view. You have a framing plan or a plan view of the stringer floor beam connections. These are floor beams in this direction, and these are stringers. They go longitudinally along the bridge. The bolded members are the fracture critical members. So that makes it easier to pick off which one of the members that the report is actually talking about. And then of course down below here you have the span, truss, the member, the type of member, and then detailed remarks on what might be going on with that member. It's also important to include a photo reference and also including the photo. Photo representation is very important so that you can go back when you're doing these reports in the future. You can see what was the condition before. Has it gotten worse? So when you get these reports, this is what you will normally see. Breaking down that report, basically each report will mention if there's any missing fasteners, if there's severe corrosion, how much section loss or how much section is remaining in those members, because that's very important for our load raters to determine what the load capacity of that bridge is. And then you have a photo reference here, and it shows you the condition of those members. What is it talking about? Basically, a picture's worth 1,000 words. Here's another example of that, where they're keying in on the pack rust here that's separating a plate, that's forcing distress on that member, and maybe it could damage the fastener. So it's very important that we have a photo log, and we very carefully describe what's going on in that member. And then as we come back the next time, okay, is this half-inch swelling in this member of corrosion, has that gotten worse? The next report is the underwater inspection report. And we have a dive team, ODOT dive team of 2 permanent divers, and we have 6 part-time divers. And these are done on a frequency of anywhere from 12 months to 60 months. And they, as I said before, they dive on our 7,400 bridges. When I say ours, that's yours and the state's. We have a total of 7,400 bridges that are 20 feet or greater in length. And when I say 7,400 bridges, they're not all over water. So I probably need to backtrack on that a little bit. But I think each year they probably inspect 750 bridges underwater, our ODOT dive team. Typically, the underwater inspection report will involve concrete members. Now, that doesn't mean to say that we don't have timber, steel, and masonry elements that support your bridges, but the majority of them are concrete elements. And so you'll see on the underwater report these elements and any defects associated with those. So on the underwater report, we take their information, when I say we, our inspectors do, and we marry it with the above water inspection, and then we combine those inspections for an overall rating. we include their elements and their defects, which here are some of the concrete defects that you might find. And the next slide will actually show, it'll be highlighted to show an example of the elements and the defects that typically our divers will see. But for concrete, Rich went over this. I know this is a lot of information to start with, but as Rich said, you can make some phone calls and ask us questions, or ask us questions during the break. But so you can have, on concrete elements, you can have spalls and delams, you can have cracking, you can have abrasion. There's a lot of abrasion and wear that occurs on columns and footings because of the movement of water and debris. So here's an underwater inspection report highlighting the elements, the underwater elements that they will inventory. So a column, pier wall, abutment, pile cap or footing, concrete spread footing, and then the associated defects. Here's an example of an underwater inspection report, and there's a lot of information on here, but they will list, as the above water inspector does, they will list a primary element and any defects associated with that. And again, it's up to the above water inspector to take this information, and if they've rated something above the water line and they find, say, a condition states 3 spall or exposed rebar, and the diver found nothing on that pile underwater, then basically that it's on an each basis, so that column would be affected by that condition state 3 exposed rebar that the above water inspector found. Or if the underwater inspector found something undermining or collision damage or exposed rebar underwater, then you've got to take that information and say, okay, well then I'm going to use their rating because I can't see underwater. I can only go down to the water line. This report also contains element remarks, pretty detailed usually. Also, some of the other items that they'll rate are the channel, the substructure, the waterway adequacy, and the Scour code. Now the Scour code is generally something we may make a recommendation, but inspectors will make a recommendation, but the only people that can change the Scour code are Holly Winston on the local side and Ed Fulton, who's our state hydraulics engineer. And that affects the sufficiency rating. So we can make the case that the Scour code is incorrect, but we have to supply those two with the information they need to make that determination. And then maintenance recommendations. They'll make maintenance recommendations, and we have to make sure that those maintenance recommendations are on the routine bridge inspection report, which is a compilation of all these supplemental reports. So any maintenance recommendations you find for fracture critical members, fatigue prone, timber boring, when I get to that, all that information must be on the routine bridge inspection report, including the maintenance recommendations. Then, of course, it's difficult to get photos underwater, but we have GoPro cameras. They do the best they can to provide us with those photos, but it doesn't always work. One thing the divers do very well is provide sketches. So they'll, on plan view sketches, they'll even provide information on the amount of undermining, so they'll have an elevation view of how much undermining there is. So they use the Excel just to draw these up. But again, having a sketch or having a photo, if they can't get good photos, then a sketch is certainly just as good. An example of prior to the AASHTO elements, before we adopted the AASHTO elements, the units of measure for footings were in each. And then now ODOT's kind of put a twist on this a little bit. The units of measure is now in lineal feet, and they wanted us to measure it along the parallel to the stream flow, or subparallel to the stream flow, which is a geological term, but basically along here You were to just to measure this, if this was exposed here, just measure that face, and that face. Well, as the divers pointed out, what happens if everything is exposed all the way around, and you have a spall over here, and you have a huge rock pocket over here, and you have undermining under here? How do you describe a three-dimensional problem out there? So Oregon decided to go to perimeter, not just parallel to the stream, but the perimeter of that footing, which makes complete sense. We talked to AASHTO, the Federal Highway, and they said that's perfectly fine. It's perfectly acceptable to do that. So I think it provides better information too. Now, getting into some of the other reports, we have, I mentioned damage inspection reports, which are unscheduled. Our seismic person, Albert Naco, put a lot of time and effort into this seismic report. Whether or not you will close a bridge, whether it's to remain open. We had a seismic exercise last June where we all got into a room and we had a scenario. We used these reports. We had the regions calling in. We had hot phones, I guess, and they would tell us there was basically a subduction zone earthquake, and we had the regions fill these reports out. When I get to the end of these damage inspection reports, there is a website that you can go to on our bridge engineering webpage to find these. So they're all posted. Along with that seismic report, we included sketches, which you may find out there after a seismic event. And photos would certainly be better, but I think that these do mirror what will actually happen during a seismic event. And if you haven't been to the first responder training through your agency, through our T2 center with ODOT, you can request that training. It's a half-a-day training on basically what to look for after a seismic event. It's excellent training. And if you have any questions, you can get a hold of me afterwards or talk to Holly or Rich about that. We also have a flood damage. So we've had considerable flooding over the years, and we have this form that's available on the website too to document scour issues. We know that you have plans of scour plans of action with your bridges, and if you go out after a high water event or there's a scour critical bridge that you need to monitor, you can even use this report to help you do that. There's also collision damage. We don't really have a report for this, but this is just an example of documenting some of the overheight collision damage that's occurred on our bridges. This is actually Battle Creek Bridge, which was raised, and so we're not getting numerous trucks hitting it and forklifts and everything else. So, from time to time, inspectors have to go out and look at a specific damage that's occurred to a bridge. And here is where the damage inspection reports are available on the bridge engineering webpage. And again, once you get these slides, you'll be able to go to that website and open up these forms and take a look at them. The next in-depth inspection report I would like to talk, or the in-depth, starting with these, the in-depth reports that feed into the routine report, is the timber boring. Now, the timber boring report, as you might imagine, is determining the amount of decay, cracking, checking in timber members. There's many different types of ways to determine that. As you can see right here, this is with a gas or electric drill, and you can see the wet fibers that are coming out of there. So, I've literally had times where I've drilled one of these caps or piles and water would pour out for several seconds. It's just like it's a water jug full of in that member. So we use, like I say, in the past we used gas drills, which were quite noisy, pretty stinky with using gasoline. Electric drills, your batteries would with a 3/8 inch bit, would not last very long. And so you can always also use an increment borer, but what we've done is we've bought what they call a resistograph. And measures the resistance. It's just a small, looks like a piece of nine wire really, number 9 wire, and it's got a small bit at the end, a high revolution bit that goes through the timber member, and it measures the resistance in there. So if it's a flat line, you can get it on graph paper. You can either have a vertical scale that shows where you're at in the timber member, or you can actually have a stylus that draws on a piece of graph paper. And when it's a flat line, that means it's full of rot, or you've hit a split or something like that. It's actually pretty low tech, pretty expensive. They're made in Germany, but it's really helped us to determine whether that particular member has to be replaced. And then the good old method is using a 3-pound hammer to sound the timber. I worked with a gentleman who he could tell whether there was within 1 inch how much rot was in that member, just by sound, and feel and rebound from the hammer. So we require all of our inspectors to sound the timber members, 100% of the timber members, and then when it's time to actually bore the entire bridge, or if they find an indication in that member, then they need to drill it. And we've even gone to the point of requiring a resistograph, because it just gives you the results, and there's really no lie about it. It shows you what's in that member. So as we mentioned before for the fracture critical inspection and the underwater inspection, the timber elements, when you do your timber boring, you're not going to really indicate, you can on your report indicate what the condition state of that member is, but that will all be summarized in your routine bridge inspection report. So there's many different timber elements, as you can see here, and I know that many of you have slab decks, you've got timber piles, timber caps, timber rail. So there's many timber elements that need to be checked on it and shown on a timber boring report. And here are the associated defects. Again, decay, cracking, splitting, checking. Those are the main things you're going to find in timber members. We also have added some agency elements, such as fire damage, bug infestation, and you'll have loss of bearing. You could have loss of bearing. And so all of these can be shown on your timber boring report. Here's an example of a timber boring report. It's just basically some elevation views of bents showing piles and caps. And the first bent here is actually a timber back wall, or a back wall shown. Now there's various, I think the inspectors like to be a little artistic at times on this. As you can see here, this has actually got these areas that are colored in yellow means there's decay here. But it still provides the same information. We try to, as much as we've tried to have everybody be consistent and show the same, the drawings, so you can just go from one drawing to the next and be assured that you understand what it's saying. We are asking them for it to contain certain things, and that is why the sketches are used, because you can't really write it down in a tabular format. You have to show where it's at. And on this timber boring report, the X's mean that it's been drilled here, but there's no rot found. So these X's on the report, and then you find R's, there's rot indicated here. And what we ask our inspectors to do is on, say, a cap, say a 14 by 14 cap, we ask them to drill it vertically and horizontally so that you can capture the limits of that rot pocket. Because when the load raters come in if it's a large member and there's not that much rot in that member, it may not affect the load capacity that much. Now eventually it may, but it's important to define the limits of the decay. So what do the numbers mean? The numbers in this case, in this area here, where I have it circled and highlighted, what this means is when the inspector drilled it with a resistograph or any other device, there was 1 inch of good wood, 12 inches of rot, and 1 inch of good wood. So basically you have a shell what we consider a shell. Just on the outside where the treatment was, that's not rotten, but in the inside, 12 inches of it is rotten. And then on the back side of that member, there's a shell there as well. So there's not much load capacity in this anymore. So that's what those numbers mean. You can see here that in this example, the inspector has included what the condition state of all these piling are. It's better to do this on a report rather than in the field, because you don't want to paint up the bridges with orange paint and your keel wears away, so you won't be able to see it in the future. So as long as you've done that on your report, you can go back and say, well, this was condition state 2. Well, now it's condition state 3. And again, these are all summarized on that routine report. Let's see, anything else to point out here? Let's go to another example of what you can do with the timber boring report. And at this point, it is a dynamic report. That doesn't mean we want, if a member's been changed, we don't want the 12 inches of rot to stay on the report. And you might say, okay, it's been replaced with a steel H-pile, H-beam. We don't want old information on there when there's no longer existing. But in this example here, you can include other things. You can track scour. These are a frame bent on pedestals, and there's some undermining of the footings. So you can show that on the reports as well. You can show water elevations. You can show member lengths. One of the things I did not show on here that most all timber boring reports show is more or less a parts list of how many girders there are, what the sizes of the girders are, the spacing between the girders, and that information is used by the load raters. But it's good to have all that information on there so that it's in one place to find it. You can also track the deck and superstructure conditions, so you can do a framing plan. Not all timber boring reports have this because they don't all have timber decks, and they may not all have timber girders. They may just be timber piling with the concrete girders on it and a concrete deck. So a purely timber bridge that has everything timber should have something like this. It should show where the rotten timber girders are. If you have an asphalt wearing surface over a timber slab or over a timber deck, then if you have alligatoring of the asphalt wearing surface, that's a good indication that you have decay in your 2x2s. And so basically you'll have to pull up that asphalt and replace those members. So your timber deck could have some decay in it by showing signs of aging in your asphalt wearing surface. The next in-depth report is a fatigue-prone detail report. And some bridges have all of this. Some bridges have supplemental reports, all underwater, fatigue-prone, timber, and everything. But for the redundant fatigue-prone details, what you're looking for is out-of-plane bending. You're looking for distortion. You're looking for fatigue cracks. The classic stringer floor beam connections that's supporting your deck. You'll find rivets that are popping out. You'll find corrosion and even cracks in your stringers, or even the clip angles that are holding the stringers to the floor beams. So these are basically where you would find those fatigue-prone details. And there's a list. We also have, one thing we can provide is we also have a bridge inspection program manual that shows other fatigue-prone details that to look for, and we can provide that link as well. So here's an example of a fatigue-prone detail report, and it shows the stringer floor beam connections. I could show that here you're looking at the truss lines. So you're checking for the connections, the stringer floor beam connections. You're checking for out-of-plane bending. That is, the inspector is doing that. And you're checking for fatigue cracking. It's got where you're at, what bench you're at, what bay you're in, that information. And then as you're breaking down the report, again, just like the fracture critical inspection report, the type of member, what's going on with that member, and also a photo, a reference photo of what's going on. Here's a picture of a stringer floor beam connection right here. So if there was a problem with any of these rivets, you know, that should be in this report. And if there's a maintenance recommendation associated with any of these, that should be on the routine inspection report. And we have a level of priorities for maintenance recommendations, whether that be critical, urgent, high, medium, or low routine priorities. The next inspection report, supplemental inspection report, is the movable bridge report. This is an example of the ODOT report, and it basically tracks the mechanical electrical condition of the movable bridge. The remarks and recommendations will be similar to any of the fatigue-prone, fracture critical. It will describe the condition of it, what needs to be fixed, you know, how often that should be looked at, say greasing schedules, you know, whether the electrical should be upgraded. We've done a lot of electrical work and mechanical work on our movable bridges. This isn't normally part of, if we're hiring a consultant or you may be doing your own inspections, generally you have to find an expert to do these movable bridge inspections. It's a specialized skill to do this. So currently it's not part of the federal highways requirement for, if we're looking at some of the local agency bridges, the local agencies are responsible for doing their own movable bridge inspections, either themselves or hiring it done. And then another special supplemental report is the pin and hanger report. So you could have redundant pin and hanger assemblies shown on fatigue-prone detail reports, where you have several rows of girders and they're connected with a pin. So you might have 10 girder lines. So those are redundant girder lines with pin and hanger assemblies. Or you might have non-redundant pin and hanger assemblies where you just have 2 girders on a fracture critical bridge. And so if one of those pins were to fail, that's not a good thing. So those have to be looked at every 24 months. So here's an example of a pin and hanger report. You see the girders being connected. Here's this may or may not be redundant girder line. It might be just 2 girders. But here you can see 4 girder lines. So those are redundant pin and hangers. And we ultrasonic test those pin and hangers. On the local side they do it, and we do it on the state side. They only need to be done once unless there's an indication in the pin or in the hanger itself. And then one other special report or supplemental report we do are cross-channel profiles. On the local agency side, those are done every 4 years. So Rich schedules those every 4 years for the entire inventory. This is a very good indication of how your stream bed is moving, the foul wag of the stream. Is it going to undermine one of the spread footings? And so you can put original cross-section on there when the bridge was built, and then you can show multiple years of problems in the channel. So after a flooding event, you can put that on there, and so it's a lot of good information. Now, Scour is cumulative, so it's good to track that. And those are on anywhere from a 2 to 10 year frequency, according to our coding guide. But you know, from a contracting standpoint, I think Rich has just decided we'll just go with every 4 years. So that was on spread footings, on pile supported footings, especially if you don't know the pile tip elevation. You can assume them, but based on the site conditions. But it's just as important to have cross-channel profiles on pile supported bridge footings or foundations. With that, that's all I've got. There's a lot of supplemental reports. You should be getting copies of all those reports, or you can go to, if you've got access to the bridge inspection webpage, you can pull those reports up yourself. But I know that I think from an easier perspective, I think Rich has been sending those reports to you so that you've gotten a copy of all those reports. I know going through this the first time is probably difficult to remember what you're looking at, but at least you've got an introduction to it, and then if you have any specific questions, you can, ask one of us about it. Do we have time for questions? Okay.
Report, do those usually come together?
It depends on the frequency. A fatigue-prone inspection may be every 6 years. Fracture criticals are every 24 months or less. And a fatigue-prone inspection report could be, it could be up to 10 years, every 10 years. It depends on the, now you might say, well, an inspector gets the access equipment out there or climbs on it and is up close and performs that inspection anyway, but they're not required to fill the report out. And if they find an indication, we have inspection frequencies in our coding guide that if you have certain things in certain condition states, say you find fatigue in condition state 2 or 3, it might drive the inspection frequency on a more often basis. So you may or may not get those reports together, but they'll be on the even years. I mean, it won't be on some odd year. You want to make sure that when you're out there, you're doing the routine fracture critical and fatigue prone inspection, if you can, rather than having to return. Of course, sometimes it doesn't always work out with access equipment and things like that because, again, the routine inspection is a visual observation. You can do it with binoculars, you can do it with a drone, you can do it with just, the naked eye. But if there is a date entered on your routine inspection report, so we have a list of dates and when the next inspection is due, you should receive it on that, for that year that inspection takes place.
Because the supplemental one or the inspection routine one is every 2 years. So do you have the most recent supplemental put on the most recent routine report?
Yes, that is correct.
Access?
That is correct.
So you don't have to go to the year that it was done?
No. And it is quite a task to take all this information and make sure it's on the routine report because you have the underwater report, you have the fracture critical, the fatigue prone. One thing that Federal Highway has asked us to do when we're out on quality assurance inspections, you need to have, what are the maintenance recommendations on the fracture critical members? What are the maintenance recommendations on the fatigue prone members? I would like to see them on the report so that I know that the most current supplemental report has all that information on the most current routine report. The divers, their schedule is probably the most volatile because of high water events and various schedules of all the inspectors. So you really have to find the latest report and make sure that information is on your latest routine report and look at the dates. So I know Rich tries his best to get you all of the supplemental reports and the routines all together with the routines. So the routine report so you can look at all of those. But that may not always happen. Do we have more time for questions, or is it break time?
I think there was a short break.
Okay.
So we have like 5 minutes before a break, and I'm just curious if we could go around the room, introduce yourselves and from where, and maybe that would and then maybe a short, like what you want out of it. So when we do presentations, maybe we could highlight it for you.
My name is Steve Gallup, and I'm from the city of Eugene. And I was mostly interested in kind of the changes in the routine inspection reports and stuff like that, the first little part that we did.
Hi, my name is Nifa Pyatkov. I'm with Quincy Engineering, and same, I was just here to know the differences between the old inspection and versus the new AASHTO format.
My name is Courtney Davis. I'm with KPFF in Portland. I have done the WashDOT side of things in Clark County and such, and want to better understand, Oregon's reporting and kind of compare those.
Brad Lemhouse with Lane County Public Works. Same thing, just learn more about how can I use the report for information when I'm going back through looking for information on a bridge or something.
Tony Stevens in Lane County, just learning how to read the reports.
Troy Thompson, City of Salem, just a refresher on how to read the reports to make sure that I'm getting the information to the people that need to get the information. And then just deciphering all the information to get to the right people.
Danny Ortiz, Jefferson County, and I just really wanted to become more familiar with the reports.
David Kudna with the City of Lake Oswego, just the same as everyone else, just want to learn what's on the reports and how to read them.
I'm Bill Anderson with Yamhill County Public Works, and being trained to assist in small bridge inspections, so I was interested in learning the terminology, the jargon.
And I guess that's everybody.
Okay, thank you. You earn a break, so we got 15 minutes. We can't eat in here, so we do have, little things out there that you could eat in the lobby and drinks. Hey, thank you. We'll see you in 15 minutes. nice refreshments and a little bit of drink. I'm just going to introduce myself. I'm Holly Winston. I'm local agency bridge standards engineer. I've been with the ODOT for 25 years, and I was in design for 14 years, and I was a seismic engineer for 3 years, and now I'm working with the local agencies. By the way, I graduated from college when I was 5, so I just want to let you know that. So the presentation outline, we'll talk about background information on the Scour, and then current status of Scour and unknown foundations, and examples of structure failure from Scour, and then what local agency could do, and then and conclusion. Background information. FHWA did a study showed that 60% of the time bridges fails due to scour. So we hear a lot of information about earthquakes. Now it's a pretty big. Oregon has done a really good job of resilience and seismic failures, but that FHW study showed that's only about 1%. It's pretty low on the totem pole, but scour is the main reason the structures fail, and Oregon definitely is that 60% with all this water, rain, especially this year. I'm just getting a lot of rain this year. And the reason that we're talking about it, because 60% of the time the bridge fails due to scour, FHWA made a major change to April 2017, and what that did was scour was just a 113 scour was something that inspectors used to rate, but that 2017 it said if the structure scour is 2, then substructure must be 2. That made things change drastically. What that means is that all of a sudden, when you had a sufficiency rating 70, it could go down to like 17. And just imagine when you had a 70 sufficiency rating, all of a sudden inspection report comes out 17, you might be a little bit surprised, and some people might have even panicked what have happened. So that was a pretty significant. So, and by the way, we had about 400 of these things our system. So we were pretty concerned about that extreme change. So not only that your sufficiency rating changes, with that substructure becomes 2, there's a whole other things trigger. For example, it becomes now 24 months, routine inspection becomes 12 months. And then of course, then we have to do a critical follow-up every year. So it becomes a much more work for everybody involved. And then of course, if you are Scour 2, then you got to do a plan of action, which I don't know if you remember. I did most of that for you. Hope that you have them and remember it. So, and like I said, we had 400 Scour critical, so we had to think really fast what to do about those problem. And just to go what that rating is, just Scour code is but Scour code is different than what Richie went on from 0 to 9. It kind of follows, but it doesn't. Like N is not over the waterway. You wouldn't have other ratings, N, or you would have an N, but you wouldn't have a U. And Scour code has U, which is Scour unknown foundations, and I'm going to be asking for your help on this one. When you build something like a bridge, and if we don't have any documentation, it becomes a Scour critical, and also we have to have a plan of action. So it is really important that we have all the documentation. And 7 is that when you see a scour and then you go do something to it, and that means a countermeasure happened and installed. And then 6, this is kind of sort of off. 6 just means that it's pretty, a lot of times it's new. I haven't gotten to code 8 yet. So 6 is sort of like, so it does not follow the traditional 0 to 9 thing, but it would happen. So here it follows a little better, like a 5. If it is any other rating, 5, you say fair, you start to worry about it. With the Scour, 5 is fine. It's, foundation is stable, and Scour also could be Scour critical by calculation. So what that means is that everything is fine, and by calculation, calculated Scour is fine, so 5 is good. 4 is fine too. So that's the thing is about local agency. They receive a 4 in the Scour. I get a phone call and say, it's a brand new bridge and it's only 4. Well, it's not a really big problem. It is still is stable and we're okay, but that means that they show some like abutments needed to be protected, and probably a lot of times what local agencies do is that they don't want to get permits, so they end up not putting riprap. So it end up being a 4. A lot of times I read the hydraulic pour says that it needs a riprap 200, and I go on the field, there's no riprap. That becomes a 4. It doesn't mean it's not unstable. It means that it needs some riprap. This is where it started to get bad. Scour critical 3 means unstable by looking at it or calculated. So there it is, perfectly fine looking. The footing is not exposed, looks fine on the field, but by calculation, hydraulic engineer, we do calculation, it seems to be unstable. And then we have to have a plan of action. And then Scour 2 becomes pretty bad. This is why we were concerned. We had a 400 these when that, and all these will go to substructure go to 2 and trigger a lot of things like I talked about. FHWA inspection 12 months instead of 12, and then underwater at 12 months instead of 24 or 48 months, and critical follow-up, those things. So that's why we were very concerned about it when we got this different changes. And then, of course, we have to see if that scour is extensive enough to be worried about. And of course, one is just really bad, and you got to deal with it right now or close the bridge. So that gets pretty serious. So back to when 2007 when that MBIS changed and we were concerned about 400 bridges, I had to kind of figure out what to do with those 400 bridges. So I wanted to go in, they're a 24-month cycle, but there are some coming right up, and I need to take care of those first. So I had to immediately get on field and verify that they are extensive. And also I want to make sure that if it was, Baker County had one bridge, I was willing to let go of that. But if it turned out Baker County had 35, so I ended up making, that was one of the primary counties did. So I had to look at what county had most of them, and then I also had to look at what inspection cycle was coming up, so that when inspector got to the site, they could look at my notes and see how to rate that substructure. So then I wanted to also talk about what the fixes would be on the field. So, and then of course, if it is truly Scour Critical, we had to talk about plan of action. So that was sort of what the strategy was when trying to figure out what to do, meet that 2007 MBI change. That was, to us, it was drastic change. And by the way, that's when I first started my new job. It always happens that way, right? When you get a new job and things change and you got to deal with things. But that was kind of fun and good running start. So I had to reevaluate all the Scour code, and then I had to say, hey, if you had some documents, and I went to all the cities and counties who had a Scour code too, and I asked them to see if we could get a copy of those documents so that we could be more accurate our evaluation. And then once we got finished with the Scour field trip, I upped it in the Pontus, so inspector went out after me. They could code it correctly in the inspection, and then we definitely talked about how the Scour code Scour should be fixed or it's stable, and then we talked about Scour plan of action. And like I said, initially it was very new for everybody, including myself, and so I just took the plan of action and I just did a generic filled out everybody on all of them, and I gave it to local agencies by email, or I just physically handed to them when I met them on the field. Some of them I did both. But regardless, the POAs embedded in your report, that if you could get online access your report, you could get them online too. And then of course that with the plan of action, you require detours map, and I had like 5 interns that worked for me to get those detour maps done for you initially, so that you guys have that, and then you could take a look at it and you could change it as you want to, and then I also provided that for you. So just a little quick summary of what we did on the field. I did there were 400 Scour code, but then we did a lot more than 400. I think it ended up about 700, and make sure that if we were in the area and there were bridges need to be looked at, we looked at it. So now 345 bridges we did not think that they were too, because they were not extensive. We definitely make sure that they were not just fill in, and that so we decided they were not. So then 150 of them went to 3 code, and then some of them went non-critical. And then out of that 445 remained 2, and then so that's the thing about Scour Code 2. It has upside. I mean, it is bad that your bridge is bad, and there's no question about that. But that allows, because that FHWA says scours 2, the substructure turns 2, and it drops, sufficiency rate drops to like a balloon, I mean lead, not balloon, but like a lead. That gave you sort of helped you with any kind of bridge funding. So it's not always true, because the formula it has a different portion of it, but sufficiency rating is portion of it. So that also helped. At the same time, it was bad that your bridge was Scour critical, but also helped you getting some funding for some of the bridges. So I think that's where that went. And because I asked for documents, we got to remove 175 bridges from unknown, so that we can, and also if it's a Scour critical, then we'll have to move it to Scour critical. But we got some documentation, so I got to remove some of those unknown foundations. So our trip, I believe the trip was very successful, and I got to meet most of you. So with that, right now we have only 23 Scour Code 2, 22 already been replaced. Like I said, because the efficiency rating is so low, that it competed very well for funding. So another 8 is being replaced right now, and then 3 of them next cycle. So we're working all those 2s down, and now I think 1 is scheduled to repair, 2 is scheduled to be replaced. So we still have a whole lot of Scour Code 3, 580 of them, and then we got more unknown foundations, and we're looking for those documentation still. So some of the unknown foundations happen because OTR 3. When we did OTR 3, we just gave you the money, and once that you guys built the bridges, you kind of forget and move on to something else. So meantime, I don't have any documentation to evaluate the Scour, so I had to send letters to all those owners asking for that. Some of them responded, some of them didn't. And then I would have to ask for a consultant if I could track down the consultant. Well, that wasn't very successful sometimes. So, and then I got smart and I decided I'm going to put that requirement into our IGA, government agreement. And I'm hoping that that would work at this point. And then also, I think one of the biggest thing is that they didn't want to send me these big Mylars, full-size Mylars. So we internally talked about it and say, we just need the document. We didn't care whether it's in full Mylar or what. So now we're requiring PDF. Electronic is fine. So I'm going to just show you some of the examples of some of the failures that I dealt with over the years. And these are all local agencies, and tell you why Scour is really real and important. So this is Yamhill County. This was a little bridge. It's a lot smaller than what the of course channel is. You had Rich talk about channel and adequacy. Well, this was not very adequate, so he scoured out. Actually, the pile was kind of floating, one of the piles. So I'd say it wasn't very safe. And then I think we built a Bailey Bridge over this bridge, and then when they got the funding, they replaced it. And also they had another problem down the road, and I helped them with the emergency funding repair. And this is just a lot. We talked about, it had a terrible winter. And this is from City of Portland, and I'm if they're online, this is their pictures, and I use their pictures and ask for emergency funding, as you can see, with the bridges closed right now and have footing toppled. So as you can see, the Scour definitely working here. And we did a emergency funding. They request for emergency funding, and we were able to provide that. And again, last summer, this is the culvert that failed in Josephine County. As you can see, there isn't much left. And that culvert downstream caused a big failure upstream of Sand Creek, and they had to close that bridge down. So as you can see, the Scour, it just not just a local, a lot of times it affects other things. And they also had to come for emergency funding, and they have and the committee okay for the funding there. And this is not private, but it is like a local access, and there were several houses that can't get over it because last winter they lost the bridge, and they didn't really have a footing. they just had like a mud sill and it lost. And I talked to one of the representatives, and they were thinking that they were going to drive some piles and do it right this time, because really the federal funding do not cover the local area of other agencies, so they're on their own. And this is kind of very dramatic salmonberry failure. As you can see, this is from Tillamook County. When I first started, I hope Tillamook County like do cost analysis, rehab versus replacement, and things like that, and help with emergency funding. Railroad, it was pretty awesome. We couldn't. It was too big a structure. We couldn't do a Bailey Bridge there. Again, Tillamook County, Big Culver failed, and there was a big hole there they couldn't get over. So we put a Bailey Bridge over Culver, and this is Tillamook County and myself built it after we done the Bailey Bridge. So we now after Bailey Bridge, we went through with the ODOT, and Tillamook County built the Bailey Bridge, and then we had an error on that. I don't know if you guys remember error funding. When we did that, we definitely championed for them to get funded. So they got funded, and then they replaced the bridge, permanent bridge, instead of Bailey Bridge. Because Bailey Bridge is like we rented to them 6 months. And this is a Baker County. Like I said, Baker County had a lot of structures that were Scour critical, and I identified a couple of them that needed to get funded, but they were not able. They didn't think that was necessary, and then they lost 2 bridges that very winter. So. One of them we did a funding ER, and the other one I think still, I believe they're still out there being not accessible and failed. Oh, this is Marion County, 2011, and Culver failed. So we looked at putting in maybe use lab ODOT had and put it in, and they decided that that's not the way to go, and they end up replacing with the Culver. This one, I heard about it and just got it from internet, Clackamas County, and got the picture, but I wasn't really personally involved with that one. So a summary of all the bridges that I've been involved on Scour. As you can see, it really, we do have problems with this Scour. Every time we have these big storms, we have local agencies that suffer from bridge failures. And it's just a tabulation of some of the solutions we worked out with the local agencies, like Josephine County. I went out in the field, looked at and documented and championed for emergency funding. Tillamook County, similar things like we talked about. City of Portland, I didn't go. Bruce himself went out and looked at that and decided that they're eligible. Baker County, we talked about that. We went out and documented, and then championed for one of the bridges to get, and the other one I helped them with the plan of action, because if your bridge failed, you have to have a plan of action. You should have a bridge plan of action anyway, but same Marion County, and then City of McCoy. It was one of the thing. It was the big truck went over it, and I'm sure that Bert's going to talk about that. So it's something that little bit off the bat, but I put it in there. So local agency involvement. I just wanted you to know that your bridges get inspected every 24 months, and by law we have to have consultant do those inspections. And consultant, I believe by their contract, they have to contact you when you're when they're going to inspect your bridges. It's in their contract. So Rich is shaking his head. Yes, he oversees the contract. So if they don't contact you, you could contact Rich and ask them when the schedule is. And I think it would be very good for you to participate in that inspection. It goes two ways. You could ask questions about now what they're looking at and learn about it. Two, you could update them what's happening to your bridge. So it is sort of two-way street. So, and also if there's any changes that inspector might not catch, and you might know, and then you could let us know, because that helps us evaluate the Scour. And Scour is not just visual, it is all a lot of it is documentation, calculation. So that's why I'm the only one who could do it, because the inspector only has a piece of information that we try to do a whole picture when we evaluate the Scour. So that's the reason that only one person does it for the local agency and one person for the state. We want you to be very due diligent sending those documents. As I've pointed out, it's really important for us to have this document for me to evaluate complete and accurately. And if you don't have the documentation, most of your bridges are done by local agents, for consultants. So I really appreciate it if you could follow up and have them send it to me. That would be great. So just want to let you know what I require. I just want to go over again. I need the as-built plans to see what was built, and then of course we need the foundation report, what's on and that's one of the main reasons that it becomes unknown, because we have no record of what's built, and inspector can't see, none of us can see. We haven't developed that Scour yet, unless we spend extensive amount doing some, probing, non-destructive. And then, of course, we need to know how deep those piles are, or drills, because without knowing that, if we know when we did a Scour calculation, it is 10 feet, and we don't know how far the foundation is, that becomes a Scour critical, because we don't want to take chances on it. So it is very important that we have those pile records. And then, of course, we have to have a hydraulic analysis. If you don't provide us, then we have to do it, and it costs us a lot of money, and we will do it preliminary enough to evaluate that. And by the way, I don't know if I told you there are 4,500 bridges local agency side. 4,000 of them are over the water. So there's a lot of work that we have to do. And then we also ask for load rating. And I'm sure, again, Bert will go over that. In conclusion, we would really appreciate it if you give us any updates with the repairs you made, because that would help us. Like I said, Scour code is different. When you remake the repairs, it becomes a 7. So that would make things easier, and also helps be more accurate and keeps us informed. And when you go see any changes, you should make plan of action, update your plan of action, and document any, in that plan of action, you should document history of fixes. And then definitely when you're Scour code 3 and lower, you do need to go and monitor at a high event. So maybe you would have gone out several times this year, because there was so much flood this year. And then, of course, as things change, you should update this detour route on the plan of action. So that brings up to our presentation. Is there any questions?
How's the local agency notified of the consultant?
Okay, so your inspection team should be either by phone or by email. Generally, it's by email. I know for out here, let's see, Ayers and Associates has the Area 3, which is Lynn, Benton, Polk, and Lincoln counties. And I know that Rick Maslin will send out an email, generally 2 weeks to a month out, notifying, like Wayne Mink. He'll send it to Wayne and say, I'm going to be out there. We're going to look at this group of bridges, and we expect to be out here at these certain times.
Does ODOT notify the agency? It seemed like in past you guys used to do that. I don't know if you do that still.
No, because it's really up. We can't direct the consultants how or when to do their work. We have to tell them when the inspections are due. They have to be done by a certain time, but it's up for them to schedule their time.
I just mean of who you selected.
Oh, who we selected? Yes, we do after the RFP has been finalized. The next contract that we actually negotiate an RFP will be coming out in 2018. So we have to go through the RFP process, and when that happens, we'll be doing a notifying you which areas and which consultants have those areas. But if you don't hear anything, if your inspectors aren't getting in touch with you, please do get in touch with me so that I can gently remind them that they need to be getting in touch with you. Because like Holly said, it is really important that you go out with them at least occasionally to make sure you understand what they're looking at. And it's a lot easier to discuss what maintenance recommendations are being looked at.
Okay, if you don't have any more questions, I would have next speaker, Bert Hartman. Bert's been with ODOT for 17 years, and he's the bridge program manager, and I would say he's the heartbeat of the bridge section because he does funding for both local agency and the state, and he gets into pretty much everything that you want to hear about bridges, and he definitely sees the load raters, overload raters, so he'll be talking about that. And like I said, with the Memorial Day being yesterday, Bert also was in Air Force. He serviced Air Force. So he's still now. He flies airplanes. He talks about he almost made 2 Mach, not quite. and so anyway, please welcome Bert Hartman.
Okay, we're going to talk about load rating today. It's a truck from the 1930s. If you look at the door there, if you can read it, it's 15,000 pound gross weight. I don't know if that truck's overloaded or not, but that's my dad, and it's one of his favorite pictures. So we're going to talk about design load rating. We'll talk about the standard legal vehicles that were used for load rating, then the specialized hauling vehicles. We'll go over load posting signs, and then finally we'll touch on the emergency vehicles. So the purpose of load rating is to preserve safety for those who are using our roads and also to preserve our infrastructure. I took this picture when I was in the Philippines, and the San Miguel Beer Company actually had it right. you do want to slow down if there's a weak bridge. You're going to cut your impact loading down. So for the local agency bridge selection, they use what's called the TRS formula, and that's has several factors in it. One of the factors is the sufficiency rating factor, and load rating plays a very important role in the sufficiency rating factor. It's also the load deficiency factor, which is purely based on load capacity. So you can see that having an accurate load rating is really critical during the selection process for local agency bridges. However, it's also important to know that the TRS is only used for replacement of small bridges. Local funding is divided up into big bridges and small bridges. The big bridge owners, they get together and they divide the money dedicated to the big bridges. So the small bridges that are being replaced, they use this formula and they pretty much stick to it. However, for rehabilitation projects, such as this covered bridge, the technical ranking score is not used. So it's just for small bridge replacements. So when we talk about load rating, we talk about rating factors. That's simply a ratio of the safe level of loading divided by the load of the vehicle considered. So we can get some practice on this one. We've got a combination vehicle, and that has a 12-ton limit. We'll say the gravel truck was way more than 12 tons, so it'd be a rating factor less than 1 on this bridge. We look at the more in-depth look at that formula. The numerator, we've got capacity minus the dead load, so the bridge has to hold its own weight up. So what's left in the numerator once the dead load's gone is just the capacity of that bridge to carry live load. And then the denominator is live load plus impact. This bridge was posted at about 18 tons, and the tractor and ammonia was about 35 tons. Here's the load rating you're going to see on your inspection reports. We're going to go step through every bit of this. There's a lot of information there. So at the very top, I don't have it highlighted, but you've got the rating date. This was from November 2016. Then we got the design load, and there's a code that's listed there below. This happens to be a 4. It's an H20 truck. So you can see that after the 4 it says M18. That's a metric designation or description of that truck, but it's an H20 is a design truck on that. What that looked like was 8,000 pounds on the steer axle, 32,000 on the second axle. Now these are simply design trucks. They don't exist. Maximum axle load is 20,000 pounds on an axle. So these trucks are just for design purposes. They're not for posting purposes at all. The next truck that was used for many years was the HS20, and that's simply a H20 truck, and they put another 32,000 pound axle in the back. And that was used primarily during the interstate era. The current design vehicle is simply the HS20, and then we put a 640 pound per foot lane load on it. It's called an HL93. And the reason we did that was you can't build a truck that has a lane load on it. So we designed a design truck that we thought would work for us. So the next section may be called the operating load. And right below that is the inventory rating. And these are based on the design load. So for operating and inventory rating, the operating rating is the absolute maximum load to which a structure may be subjected. And the inventory rating is the load level which can safely utilize the structure for an indefinite period of time. So here's a Single trip permit moving. This would be like an operating type load. If you look really closely at the deck, you can see it deflecting down. You can see those girders are probably 6 or 8 feet tall. So this is a kind of a load you're not going to want to routinely see on your bridges. The inventory rating is a factor used for the sufficiency rating calculation. We talked earlier about temporary repairs, and no credit is given for temporary repairs with the operating and inventory rating. Portions of the bridge are supported or strengthened by a temporary member and will be rated based on our actual condition. Temporary members are not considered. So, but if you do temporary repairs on a bridge, then you do get credit for them for the load posting situation, but not for the inventory and operating rating. So if you have a bridge in poor condition that needed temporary repairs, it'll have a low inventory and operating rating, and it will compete well for funding. We don't want to discourage people from doing temporary repairs to keep a bridge in service. We don't want to penalize you so that you won't apply for funding. So this really helps out. So now we go over to the upper right. We've got the posting required. Again, you've got a code. This code says 0, and that means it's greater than 39.9% below what it should be. And that's simply a summary of, you can see what's highlighted in those little circles there. There are many trucks here that this needs to get posted for. So the bridge actually is posted for load, and you can see on the in the left-hand square, post remove, all the rating factors are less than 1. % below is all well less than the code of 5. And you can see the actual posting on that for each of those trucks and the posting date. So the posting, that's item 41. There's many codes that are associated with that. The most common ones by far is open, no restriction. And then there's open, posting recommended but not legally implemented. And that can be if there's no warning signs or inadequate warning signs, or maybe the a sign's been damaged. And then P is posted for load. Next we get down to the method of load rating. This is, again, it's a code. It's for LRFR. And what that is, it's our current load rating method. All new bridges are nationwide are getting load rated with this method. Oregon's chosen to use this method on all of our older bridges too. We had a problem with shear cracking and concrete girders, so we were a early adopter of the LRFR method, and we're going back, we're getting all of our bridges updated there. And not all states are doing that. A lot of them are using the older methods for the older bridges. So here we have the standard legal loads, and we've got the rating factor we talked about before, the safe level of loading divided by the load of the vehicle considered, and then there's the code involved there. This says postings required, and then also talks a little bit about what the controlling member is. This one looks like interior girder in span 5, and it's positive moment in midsection. Here's what the standard legal loads look like. Here's a type 3. It's a single unit vehicle. Axle weights on those are 20,000 max single, 34,000 on a tandem, 50,000 pound total weight for this vehicle. The 3S2, S stands for semi. It's got 3 axles up front and 2 axles on the trailer. This is a classic semi, 80,000 pounds. You see these all over the highways. Here's the type 3-3. Again, it meets the bridge formula weights. It's 80,000 pounds. So now we get into the specialized hauling vehicles, and it's just kind of fun to look at these trucks and count the axles. Typically you have a steer axle, a tandem axle, and the rest of them are all going to be drop axles. And we'll go through every one of these now there. This is the 4-axle truck, and when I first started giving these presentations, I received some negative feedback that the trucks weren't in Oregon. So I went back and found some more pictures. The building on the lower left, that's the state capitol building. You can see that right from here as you walk out. So these trucks are in Oregon. And the more you look for these trucks, the more you're going to see them. The 4-axle configuration is very common, typically with dump trucks, concrete trucks. That garbage truck looks like the truck that comes to my house. So very common vehicles, 54,000 pounds, 4 axles. And again, you got the, you look at the tandem, 34,000, it's just a standard tandem. Get to the 5-axle truck, 62,000 pounds. Again, a classic garbage truck configuration. And then the Knife River concrete truck. Now that last axle for the concrete truck is a much larger wheelbase. He can actually carry more weight than that 5-axle garbage truck. For load rating purposes, we use the tightest configuration we can get because we can't load rate for everybody's truck. 6-axle truck, 69,500 pounds. That truck on the lower right is just a good-looking truck there. And we get the 7-axle trucks. 77,500 pounds. You don't see too many of these in Oregon, but if you do look, you'll see them. I've seen them in Oregon. This is off the load rating summary sheet of a state highway bridge. Why I brought this up for you is that far right-hand column is rating factors, and you can see it's an older bridge, so HL 93. Rating factor of 0.55, well, that's what we'd expect for an older bridge. It was never designed for the HL93 loading. You can see the rating factor for the Type 3, 3S2, 3-3, all over 1. The next section is the specialized hauling vehicles, and we'll put the rating factors less than 1 in bold print. As you can see, the 6 and 7 are just slightly below 1. Then we got the continuous trip permits. They're above 1, but I want you to look at the very bottom part, the single trip vehicle. Those are these operate on single trips, and you can look at the rating factors there, like the second one from the bottom, 258,000 pounds. Rating factor is well over 1. It's 1.22. So it's not just the weight of the vehicle, it's how concentrated the loading is. And we'll see this quite a bit of time, that the bridges that need to be posted for these trucks are less than 80,000, yet they'll be just fine for these trucks that are 258,000 just because they spread the load better. This is a deck arch type bridge, and it just shows that the different parts of the bridge. So usually bridges aren't as complicated as this, but you can find out what's actually controlling your load rating. We're under a program right now to get all of our bridges load rated, but until they do, we put default data into them. You'll see the method of for operating rating, no rating or evaluation. And of course, the rating factors will be blank. We should be getting away from this really quick, though. This is a bridge that's it's posted, but it doesn't require posting. You can see in the upper right hand says it's at or above legal loads, and the rating factors in that left box are showing all above 1. But an owner can choose to post a bridge less than what the rating says. So we have a load rating comparison chart. You can look and see the condition the bridge was at when the rating was done, and looking at the current condition. In this particular one, the substructure went from a 5 to a 4. And then we look at the maintenance recommendations. Those have a priority to them. These are urgent maintenance recommendations. Looks like we have some piles with some pretty serious rot. So we should be updating these load ratings as conditions change, but if you do see conditions change with an older load rating, you may want to highlight that to us. So for load posting signs, there's just a variety of signs that are used. Typically the one on the left with a single tonnage, that's for 10, 15 tons or less. Then the posting sign on the right is typically used for local agency bridges with the 3 truck silhouettes, but those other signs are all available also. So we need to have the load posting sign actually at the bridge, and then there also needs to be a warning sign so that the driver can make a good decision and not drive over that bridge. These are advanced warning signs. This is for a state highway bridge. You can see he's got the he's good for all legal loads. Actually, a 20,000 single, 34,000 on a tandem, up to 105,500. He can do a standard chip truck or a fuel truck, but nothing above legal axle weights. Here's an example of, we talked about the posting status of B, open, posting recommended but not legally implemented. And so although there was a sign there at one time, it's pretty well damaged and is not usable. So that would be coded as having a B. When we got to the specialized hauling vehicles, we were told to post these bridges for specialized hauling vehicles, but we got no direction on the what the sign might look like. And it took an extended period of time working with local agencies and the freight industry. We finally came together on a sign, and there's no perfect sign. There's a whole bunch of information here. We need to communicate to a driver operating at speed. So the Oregon sign, if we have posted for all legal vehicles, is on the left there. It's that horizontal line in the middle kind of divides it between the single unit trucks and then the trucks below are combination vehicles. We tried all sorts of different words on the signs, and it just got too busy. So that's what we came up with. If a bridge only needs to get posted for the specialized hauling vehicles, we can use that sign on the right. And there's we only list the vehicles that actually need to be posted for. So sometimes you'll just see one that says 6 or 7 axle trucks on it. This is the proposed national sign. It's still under review right now. Actually, it's a pretty good sign. It looks very similar to ours. Maybe it's easier to read. I'm not sure if we're going to go with this sign or not, but it's very similar to our sign. And now we've got the very bottom of the inspection report. This has just been added. These are emergency vehicles. And we got these as part of the FAST Act. And the FAST Act, it covers emergency vehicles on the interstate, and it gives them heavier axle weights. In fact, you can get 62,000 pounds on that tandem axle on a fire truck. So you can imagine that we had our whole nation, we had to re-rate all of our bridges for these specialized hauling vehicles. We were concerned with 5 axles, 62,000 pounds, and now we have vehicles with the same weight on just 2 axles. Of course, if you're in the heavy rescue business, you're going to feel a little bit silly showing up with a little truck, and you're probably going to want to have the biggest, baddest truck you can get. So that's what they've got. Now we're going to be including those emergency vehicles in all of our future load ratings. For local agencies, they're simply going to be for information only. We're required for the interstate highway system and 1 mile either way to put posting signs up for these trucks. However, I doubt these trucks are operating just on the interstate system. In fact, they may be operating on some local agency bridges too. And we're very, very early in this effort. We've just simply got the database updated. We're still working on our tools, and then we'll start evaluating bridges for these vehicles. That's the end. Any questions on load rating? Load rating is based on a change in condition. So, yeah, you can have load ratings that have been many years old, but if the bridge is in that same basic shape, what we do in load rating is if the condition factors change, then we have factors in the load rating that change also. So, a bridge that's in poor condition is going to get. We're not going to count all the strength it had when it was new.
I can answer that one. So the inspector will be out in the field, and say if they saw that there was fresh asphalt put on top, or there's a change in the condition on one of the girders or something like that, what they'll do is in the maintenance recommendation section, they'll put in a recommendation, they'll put the group responsible, they'll put load rating group, so it flags, and then they'll say what to do, like update load rating due to new AC, or they'll put the location like girder 1, span 3 has a crack. But what Birch Group then does is they'll do a query for all the local agency bridges, and they'll find all those that have that load rating group flag, and then they'll go through and they start to put that in their list for their updating the inspection report or the load rating reports.
And then at that point, you inform the agency that they either need to post it or...
Once the load rating is completed, yes.
Yeah. Okay. Yeah. And if there's a real concern on the bridge, we ask the inspectors just to give us a call right away, and we'll just drop what we're doing and take care of that. So that's always available. We've had collision damage on bridges, and just basically drop what we're doing and just work on that. So it's definitely prioritized.
That works both with the Scour as well. If they actually find in a condition which there's a lot of concern over in the field, they'll notify us. They'll notify you guys as well. So besides just putting it on the inspection report.
Thank you.
On the operational inventory, the operational loading. Is that now? Can that be used?
Let me.
For the ones that are over 80,000 pounds for like single trips, is that something that could be used for determining single trip loading on a said bridge?
Yeah, if I can get the.
Yeah, the definition. Yeah.
I was gonna get that one that has that one there.
That'd probably be well. Yeah. Well, that one they're all over 1 point, or most of them are over 1 point, except for the special
right
trucks. But like on that one they had earlier, it had sometimes like say the one that's 25 tons, but that's kind of a default.
Okay. Okay.
So you probably wouldn't want to use that, but on the newer load ratings, is that something that could be used for when you're determining the strength of a bridge for single trips when you're getting up to the 150,000 pound trucks and things like that?
I wouldn't use that at all. That's simply design load rating. It's for the National Bridge Inventory. But when we do if you own bridges, you're going to have the load ratings for those bridges. So you're going to have the summary sheet.
Okay, so then we can use that number there, though.
Right. You'll have those. You'll have these numbers.
Okay.
Um,
And so we can use the 1.07, say, for the 150,000 pound vehicle.
right.
And then we just use their weight times 147, or 1.07 times the base weight to determine if the one they're looking, yeah. Well, that would be okay then.
Well, these are specific truck configurations. They're representative of those weight tables, but don't get too much into trying to use what like a specific vehicle and looking at that weight and ratioing things. It's not quite going to work that way. But you can look at it and say, like if it's like a 1.2, 1.4, and your truck's very similar to that, you'd be comfortable with it.
Okay.
We also, what we'll do is, and on your report, you're going to have, if it's single lane, so you can always put the truck over the bridge all by itself. You can put it in the middle of the bridge and really help that load distribution out. There's all sorts of things you can do.
Yeah, because that's one thing I was kind of looking at is like, if you have a long span, like 150 feet, that whole truck's going to be sitting on that bridge as it's crossing.
Right. Yeah, these specialized hauling vehicles are really tough on the short span bridges because you do get the whole truck on there. And local agency bridges tend to be shorter than state highway bridges. Although even with a long span bridge, you can have the combination of floor beams and stringers, so those individual pieces can act like they're smaller spans, but the short single span bridges, they really get affected by the specialized hauling vehicles.
Okay, we're engineers and we're very efficient. So it looks like we are going to be out of here a little bit early. I want to invite you. We want to go to lunch, so I will invite you if you want to join us. We haven't decided where. And if I'm hoping that people online, if there's any questions, please send me questions and I will respond to you because I do have access to all the experts. And also with you, if you think about something that you would like to ask, you could send me an email or you could call me. Either way, that works. Anyway, thank you very much for attending. So hope this was useful to you. Bye.